In this lesson, we're going to explore the derivative of inverse functions. First, let's refresh our memory of some basic inverse functions. So for instance, if my function is x squared, then clearly its inverse function is the square root of x, which is the opposite. If my function is e to the x, the inverse is natural log x. If I have x to the 1/3 or cube root of x, then my inverse is to cube it. And the inverse of x minus 4, of course, is x plus 4. And we do all this to refresh our memory of what happens when we plug an inverse function into a function. So let's try that with each of these. So I'm going to plug root x into x squared, and I get root x squared, which is just x. I'm going to plug natural log x in for x here, so I get e to the natural log of x, which is simply x. I'm going to plug x cubed into the cube root of x, and if I cube something and then take the cube root, I get x. And this one I can plug in x plus 4 in for x, so I get x plus 4 minus 4, and we can see that that's also going to be x. And so we should be refreshing our memory that if we apply an inverse function and then the function back to it, we end up right back where we started. So basically we do one thing to x, we undo it, we're back where we started at x. All right, so that's going to help us with learning about the derivative of the inverse function, and I'm going to take this one step at a time. So here is that f inverse x equals x. That's what we were just reminding ourselves of on the last slide. We are now going to take the derivative of both sides. So you should notice on the left side our outside function is f, our inside function is f inverse. So the derivative of f is f prime. So there you see f prime of f inverse. And then here we have the derivative of the inside, which is the derivative of f inverse. And of course the derivative of x is simply 1. And so we are now done differentiating both sides. In our next step, we actually want to solve for what we're trying to find, which is the derivative of the inverse function. And so we are going to divide both sides by this part, f prime of f inverse. And when we do that, we get this. So we divide both sides by f prime of f inverse. And now we're basically done. We've got our rule, the one that we need to memorize. All we're going to do here is rewrite that prime with a d dx. So the derivative of f inverse equals 1 over f prime of f inverse of x. Now, here's the thing about this. If you get this rule memorized, it'll be helpful, of course, for your benchmark, but it also regularly comes up on the AP exam, usually one question. But if you know it, it's easy. And if you don't know it, it's a lot trickier. So the sooner you can memorize this, the better. All right, so let's apply it to a situation. So we've got lots of questions here. I have a table here, and the first question asks, what is f of 2? Well, if I plug in 2, my output is 4. There it is. What's f inverse of 2? Well, that's going backwards. So now I'm looking for 2 in this column, and f inverse of 2 is 1. Now, what is f inverse prime at 2? This is where it really helps to have this memorized. So you say, okay, f inverse prime equals 1 over f prime of f inverse of x. Missing a few parentheses. There we go. Okay, so I'm going to just write it out. 1 over f prime of f inverse of 2. All right, so the first thing I need is f inverse of 2. That's going to be 1. So that equals 1 over f prime at 1. And f prime at 1 is 1.4. And so there's my answer, 1 over 1.4. All right, on our next problem, we're going to get a visual of what's going on. So we've got two inverse functions. You'll recall that inverse functions reflect over the line y equals x. I'll just draw that in there. And we're given 2 points. Point P is at 3,8, and that is f of x, which is what our table is on. And point Q is the inverse. That's f inverse. And so that means point Q here is at 8, 3, because it corresponds to point P. And we're asked to write the equation of the tangent lines both at 3, 8 and 8, 3. So let's start with the one at 3, 8. So we know our point is 3, 8, and we know our slope right here is 5.5. So right here, it's quite steep, right? Our slope is 5.5. And so for P, the equation of our tangent line is y minus 8 equals 5.5 x minus 3. All right, so now when we're doing Q, we've got our point again, but Q's slope, you'll notice, is related to P's slope. P's slope was up 5.5 over 1, which means P's slope's going to be up 1 over 5.5. And so we can write that tangent line as y minus 3 equals 1 over 5.5 x minus 8. And you'll notice everything switched. Our x's and our y's switched, and our slope, they're reciprocals, because here we had dy dx, and when we flip it, you're going to have a dx dy for that inverse. All right, let's take a look. This just summarizes here that if on the original function the slope is dy dx, then on the inverse it's going to be dx over dy, because when we do inverses, x and y trade places, and dx over dy is the same thing as saying 1 over dy dx, which is that rule that we learned, which is 1 over f prime of f inverse, f prime being our slope. All right, that should be everything you need to do your homework in this section.